The person pushes a broom at an angle of 60 degrees with respect to the floor. They're pushing with 40 newtons directed along the broom handle. And the person pushes a total distance of 9 meters. We want to find the work done by the person, work done by gravity, work done by a normal force, any work that could possibly be done here. So in physics, the formula is that work will be a dot product of the force and the displacement. So let's draw a free body diagram for the mop head there and see what forces would be relevant. So anything that has mass has a weight. So that mop head would definitely have some weight to it. And we can call that just Fg. Not only that, but it looks like the person's going to be pushing in the direction of the broom. But instead of putting the vector like this, I'd rather have the tail on my dot. So I'd rather do something like this. Say, okay, this is my force of push, Fp, perhaps. All right, now, what other forces are relevant? There could be a normal force. So that would point up. Normal force from the ground on the broom. Okay, so 40 newtons is force of push. They say it's a 60-degree angle. So we ought to find the components of that. We'll assume no friction because they didn't talk about friction. This will be Fpx and Fpy. Now, to make things totally correct, I should let my normal force be larger than that, because the normal force has to actually balance with the weight and the Fpy. But anyway, okay, let's find the work done by each force. So you can do them all individually. And I'll just say, okay, work done by the push. We want the force of the push dotted with the displacement of the broom. All right, so can I draw a displacement vector? I'll do it in a different color. That can be my delta R for the broom. It goes 9 meters. But look at the angle between the push and the displacement, because that's what you have to do when you're calculating work. So we could say that the force of the push has a strength of 40 newtons, and that's what we would put in when we do our dot product formula. Force of push, we want to know the distance traveled, so that's going to be the magnitude of delta R. And then we do the cosine of the angle between. Alright, so the force of push has a size of 40 newtons. The displacement has a size of 9 meters. And the theta was 60. Let's see what work the push force does. 180 newton meters. It's going to be 180 joules, capital J. Now, let's see if we can calculate the work done by other forces, though. Let's say we do the work done by gravity. You would want Fg dotted with delta R then. But look at the angle between them. It's 90 degrees between them. So even though I don't even know how heavy the broom is, I don't even need to, this is going to be 0. Gravity won't do any work in this situation if you just slide the broom across the floor. Because it's like gravity's pulling down, but the broom doesn't go down, is the problem. And then if you analyze the normal force, you would want Fn dotted with delta R. But Fn points up, and delta R points to the right. So it's also 0. The only force which does work here is the force of the push. If there was some friction, that could do some negative work, but we don't have friction in this problem.